Hello, and good day to everyone. My name is Randall Law, and in this particular presentation, I will provide an overview of my research into the stone and metal trade networks of the Indus Civilization. I'd like to begin by thanking the International Association for Archaeological Research in Western and Central Asia for hosting what has been a truly remarkable series of talks. And I specifically like to thank Dr. Uta Franca and Professor Vian Prabhakar for inviting me to present this one. This is a pre-recorded talk as I am currently away from the University of Wisconsin-Madison and on summer holiday with my family. However, I am eager to hear and to respond to any comments or questions that you may have regarding my research. You may contact me at my university email, which is rwlaw@wisc.edu, or if you would prefer something less formal, via Facebook Messenger. Let me briefly give you a bit of background on me and how I came to study this subject matter. Many years ago, when I was an undergraduate at what is now Cal Poly Humboldt in Northern California, I completed two bachelor's degrees, one in anthropology and another in geography. I was interested not only in ancient peoples, but also the vast landscapes across which they dwelled and traveled. The Indus Civilization was a natural fit given these research interests. At its broadest extent during the latter half of the third millennium BC, it encompassed a substantial part of what today is Pakistan and northwestern India. The distinctive material culture found across this geographically and ecologically varied area indicates the existence of extensive communication and trade networks connecting the ancient peoples of this region. And there is clear evidence that these networks extended well beyond the greater Indus region to contemporaneous societies in ancient Central Asia, Iran, Arabia, and Mesopotamia. It was these trade networks, both internal and external to the Indus civilization, that I wished to study when I came to the University of Wisconsin-Madison as a graduate student 25 years ago. My advisor there was Professor Mark Knoyer, a scholar that needs no further introduction from me. Since completing my PhD, I have remained in Madison, and Mark has remained my colleague and collaborator. I will acknowledge and thank many people over the course of this talk, but it was Mark who made and largely continues to make my research possible. It was Mark Knoyer that first took me to Harappa, the Indus Civilization type site located in Punjab province, Pakistan. Since 1986, he has been co-directing the Harappa Archaeological Research Project with Dr. Richard Meadow of Harvard University. Together, they and their colleagues have established the most detailed and well-dated chronological sequence of any Indus Civilization site. And it's a sequence filled with artifacts that can be used to address research questions such as my own. My research questions were not unique. They had been examined before by focusing on a range of artifact types, such as Indus ceramics, shell, and faunal materials. Along with Professor George Dales, Mark Knoyer had literally written the book on Harappan ceramics. And Knoyer's groundbreaking dissertation on Harappan shell industries traced the distribution of such artifacts from extraction areas on the Arabian Sea coast to production sites and consumers far inland. Several of Mark's students have followed his example. Dr. Bill Belcher did an ethnoarchaeological study of fish remains from Harappa and other sites and was able to trace the movement of this important food type throughout the region. And another of his students, Dr. Brad Chase, was able to track the movement of herd animals through the isotopic study of their remains at various Indus sites in Gujarat. And for my part, I decided to study the acquisition and distribution of stone and metal commodities in the Indus world. Stone and metal are among the best preserved and most immutable artifacts at any archaeological site. They are usually highly variable in terms of their material type, and, most importantly, they are essential to the development and functioning of early urban societies. They can be broadly categorized into semi-precious varieties, ones that can be used to signify wealth and social standing, and the utilitarian materials that are necessary for day-to-day tasks. At Harappa, you can walk across the surface of the site and literally scoop up handfuls of stone and metal of both types. And within the assemblage of excavated stone and metal at Harappa, there are hundreds of thousands of well-dated examples throughout its chronological sequence. I am certainly not the first to recognize the potential of stone and metal artifacts in terms of reconstructing Indus Civilization trade networks. The earliest researchers at such sites, scholars such as KBM Sanula, Ernest Mackay, Horace Beck, A.L. Coulson, among others, they devoted multiple chapters to identifying exactly what these materials were and where they potentially came from. Subsequent scholars have written entire books on specific material types, as well as on the trade networks which those materials indicate existed in the ancient past. One book that I found extremely useful over the years is Nyanjot Lahiri's The Archaeology of Indian Trade Routes up to 200 BC. To the right is my own beat-up copy, which I dragged all over South Asia in my studies. In this book, Lahiri catalogs all of the material types present at Indus sites and identifies many of their potential sources. In the introduction to her book, she writes, "A qualitative leap in studies of trade in ancient India can only happen if detailed and large-scale scientific studies on different kinds of artifacts and their raw material sources are undertaken." This sentiment became my guiding principle in my own research efforts. However, before such studies could take place, I first had to fully understand the materials that I was dealing with. So, at various points between 2000 and 2004, I examined and classified the entire stone and metal artifact assemblage at Harappa. The assemblage itself contains well over 100,000 artifacts, representing nearly 30 individual material types. However, just 5 of the material types make up over 95% of the assemblage at Harappa. These 5 are items composed of either steatite, chert, agate jasper, sandstone quartzite, or copper. In comparison, artifacts composed of high-value precious materials like Vesuvianite grosler, lapis lazuli, and gold are relatively few in number. Nevertheless, by identifying the geologic sources for all such materials, from the most abundant down to the least abundant, we can reconstruct the trade networks of ancient Indus peoples in great detail. Now, there are really 4 steps for successfully sourcing stone and metal artifacts. First, you have to locate the natural occurrences of the rock or mineral type being investigated. Following this, you have to collect a representative range of samples from each of those potential sources. Once you have your geologic samples in hand, you have to demonstrate that there is chemical or isotopic or mineralogical variability between the different geologic sources, and that variability is greater than the variability within the individual sources. Finally, You have to establish a set of analytical parameters that will allow you to differentiate the different sources from one another. And most importantly, allow artifacts to be assigned to them with a high degree of confidence. Going back to the first step, locating potential sources. Nayajot Lahiri's book was a great starting place, but I soon moved on to the excellent maps and geologic reports published by the various agencies, both government and private, in India and Pakistan. The highly diverse geology of the greater Indus region and its mineral resources are very well understood, and it was not long before I knew where I needed to travel to obtain the samples with which to compare to the Indus stone and metal artifacts that I was examining. And this brings us to the second step, collecting a range of representative samples from each potential source area. And I'm not afraid to admit it, this is where the real fun began. My quest for geologic samples took me to some fantastic places. I traveled throughout Sindh, across Baluchistan, through the tribal areas along the border with Afghanistan, into the beautiful and varied landscapes of the Khyber Pakhtunkhwa province. I followed the salt range of the Punjab and traced the course of the Chenab River into the foothills of Jammu and Kashmir, and then into the Himalayas proper, down through the scorched beauty of Rajasthan, and onto the plains, bets, and rans of Gujarat. I even managed to cross the Arabian Sea to Oman, which is a region well known to have had contact with the Indus world. I cannot say that I located and sampled all sources of every material that Indus peoples used, but for the major material varieties and many of the minor ones, I did manage to collect comparative geologic samples from each region that Indus peoples would have had more or less direct access to. I should add that I did not do this alone, and also that I never failed to meet interesting people wherever I went. And also, invariably, these local people were not only kind, but they were also highly knowledgeable about their area, and they could take me directly to where the materials that I sought were found. But really what made it all possible were the many scholars I met in the geological sciences. Above all, the late Professor Dr. Saeed Hamidullah of the Center of Excellence in Geology, University of Peshawar. He was instrumental in helping me to secure the necessary travel permits and permissions to visit some of the more remote areas of Pakistan, such as the tribal areas and parts of Baluchistan. Perhaps the most productive month of fieldwork that I had during this period was with Dr. Saeed Bakri of the Pakistan Museum of Natural History. He guided me through the Salt Range and further south into Sindh. Professor Manoj Pandit was my principal collaborator in a survey of copper mining areas in northern Rajasthan. And finally, Ashok Grover, a retired exploration geologist from the Geological Survey of India, has an encyclopedic knowledge of ancient mining sites throughout Western India. Still, as a student of Professor Mark Knoyer, I was taught not just to rely on academic knowledge. Mark showed me the benefit of questioning Jhoris, traditional stone sellers, about the materials they sold and where those materials came from. Whenever I came across these guys, whether it be in Sindh or in Uttar Pradesh or in northern Pakistan, I would stop, rummage through their boxes of rings and precious stones, and ask questions. This jury in Peshawar had a sample of some very hard to find Vesuvianite. And this one in Karachi had blocks of raw steatite, which he was able to tell us he got from carvers at the shrine of Shah Nurani in southern Las Bela, Baluchistan. So a couple of days later, we went to visit the steatite carvers at the shrine of Shah Nurani, and they told us that the material that they used came from a mine located not far away. Using the information they gave us, a few days later, we located the mine and obtained samples. The thing is, this source was not documented in the geologic literature. If we had not visited the stone cellar in Karachi and then in turn visited the steatite carvers at Shah Nurani, we would have never located this. I got similar information about the locations of undocumented agate sources in Gujarat from bead makers in Khambhat. I've got dozens of anecdotes like this, but I need to move this talk along. The point is, I was able to obtain literally truckloads of geologic samples of all varieties with which I could compare to the stone and metal artifacts from Harappa and other Indus sites. This brings us back to the third step for sourcing stone and metal artifacts, demonstrating that variability between sources is greater than the variability within sources. Documenting variability can be done in a variety of ways. It really just depends on the material that you're looking at. Sometimes basic mineralogical testing will be sufficient. Other times it might take X-ray diffraction analysis or characterization of materials using VPSEM with EDS. Sometimes more sophisticated methods may be required, such as instrumental neutron activation analysis or multi-collector inductively coupled mass spectrometry. And other times, a systematic comparative studies done at a large scale will be sufficient to differentiate certain types of stone. All of these methods, often in combination, were brought to bear on a wide range of materials from Harappa and other Indus sites. At this point, I need to state that all of this research, traveling, and analysis cost a great deal of money. There are many entities, institutions, and organizations that have supported this work over the years. I want to especially thank and acknowledge the Harappa Archaeological Research Project, the American Institute for Pakistan Studies, the American Institute for Indian Studies, the Wenner-Gren Foundation, and the National Science Foundation. And this finally brings us to the last stage of sourcing stone and metal artifacts. That is, establishing a set of analytical parameters that allow sources to be differentiated from one another and artifacts to be assigned to them with a high degree of confidence. The parameters differ depending on the material and the type of data obtained. They range from semi-quantitative assessments of measured attributes to statistical comparisons using discriminant analysis or principal components. Ultimately, we were able to use them to identify the raw material sources of the stone and metal used by residents of Harappa with a high degree of confidence. Over 24 varieties of stone and metal from Harappa were examined in some fashion. The data obtained have permitted us to reconstruct the ancient trade routes for each of these materials. While the paths of the routes themselves are conjectural, the identification of the sources are made with a high degree of confidence. This particular route map represents the latter part of the urban phase at Harappa, which is designated period 3C. Although raw materials were obtained from all parts of the Indus realm at this time, there is clearly an emphasis on the exploitation of stone and metal from sources to the north and west of the city. This is not particularly surprising given that Harappa was the Indus city best situated to access sources in those regions. By examining stone and metal artifacts from each of Harappa's chronological phases, we can see how trade networks develop, expand, shift, and contract as the Indus civilization emerges, grows, and declines. All of this is recorded in great detail in my 2011 monograph, which is an updated and expanded version of my 2008 PhD thesis. As I stated before, Harappa's emphasis on the exploitation of stone and metal from sources to the north and west of the city is not that surprising, given its geographic orientation. But what of the other Indus urban centers? Might their assemblages likewise reflect resources found in their respective hinterlands? As it happens, I've been fortunate in that I've been able to examine and, in some cases, analyze stone and metal artifacts from each of the other Indus cities. Being a student and colleague of Jonathan Mark Ganoyer opens a lot of doors and a lot of collections. I also must thank and acknowledge R.S. Bisht, Amarendra Nath, and my close friend V.N. Prabhakar. Over the past 2 decades, I have also been able to examine and analyze stone and metal artifacts from several dozen other Indus settlements or contemporaneous sites that Indus peoples would have had trade ties with. For this, I must above all thank my longtime friends and colleagues at MS University in Baroda, Gujarat. Dennis Fernez and R.S. Fonia, Professor Dr. Vasant Shinde, Dr. Qasid Mullah, and Drs. Abdul Samad and Shakurullah. Finally, I must express my deep gratitude to some giants of Indus archaeology that unfortunately are no longer with us, namely Jean-François Jarige, Maurizio Tosi, and S.P. Gupta. So, based on my work at Harappa and supplemented with observations and analyses of stone and metal artifacts from more than 3 dozen additional sites, I will, for the remaining half of this talk, discuss the acquisition and trade of major varieties of Indus stone and metal, along with those for a few minor ones. Time will not permit me to delve too deeply into the analytical details of these studies. However, if you have questions in this regard, then please feel free to contact me at one of the addresses I provided earlier. Let's start with grinding stone. By that I mean the broad category of stone artifact that includes cairns, mortars, pestles, whetstones, and polishers. These are typically made from sandstone or quartzite, but also include materials such as basalt and granite. They are not one of the sexy materials, say like agate or copper, but I would argue they are every bit as important. Grinding stones are essential for the daily preparation of staple cereals and other foods. And they are indispensable for leatherworking, bead grinding, and numerous other craft activities that took place at Indus sites. And the typical grinding stone is heavy. Some of the larger examples I weighed at Harappa were in excess of 20 kilograms. Some of the grinding stones that I studied at Harappa were more or less complete. But most examples I recorded were broken or fragmentary in some form. But whole or fragmentary, I recorded them all. And there were a whole lot of them. To be precise, there were 2,586 of them when I completed this study in 2004. Of those, 1,475 came from secure stratified contexts spanning periods 1 through 5 at the site. For each example, I recorded its rock type, color, texture, grain size, patterning, visible inclusions, degree of silicification, and its general toughness. At Harappa, there are four main varieties that make up the majority of the grinding stone assemblage. The variety in the upper left is a semi-metamorphosed quartzite of generally poor quality. The variety on the upper right is a tough, sugary textured sandstone speckled with distinctive brown spots. The variety in the lower left is a fine-grained gray sandstone. And the variety in the lower right is a reddish quartzite with distinctive hematite-filled lines and veins. The question is, where did residents of Harappa obtain these materials? Harappa is located almost in the center of the vast alluvial plain known as the Punjab. Remove the rivers from this map, and everything that you see in green is fine alluvial sediments, sand, silt, or clay. If you wish to find a rock, from the tiniest pebble to the largest boulder, you had to travel at least as far as one of these zones in red. These zones ranged in distance from 120 kilometers to the north to 350 kilometers to the southeast. Being located far from sources of any type of stone or metal is something that is true, to a greater or lesser degree, for the majority of Indus sites. There are important exceptions, of course. The city of Dolavira is situated on a rocky limestone outcrop in the Great Rann of Kutch. And other Indus sites are located directly adjacent to or even within highland areas. However, by and large, like so many of the other early urban civilizations, Indus peoples mainly dwelled on the agriculturally fertile alluvial plains. So where did they get the stone to grind their grain harvests? It turns out that the poor quality gray metaquartzite came from the nearest available source in the Karana Hills, 120 kilometers to the north of Harappa. The brown speckled material at Harappa is what is known as Pab sandstone. It comes from the Suleiman Range, starting 220 kilometers west of Harappa. Pab sandstone is a high-quality grinding stone that is still used for making large rotary millstones today in Pakistan. The gray sandstone cobbles at Harappa most likely came from the beds of one of the many rivers flowing through the Himalayan foothills, 300 kilometers to the northeast of the site. One of the most interesting discoveries was of the reddish quartzite found in the Kiliana Hills, which are a distant outlier of the Aravalli Range in southern Haryana. Here, and only here, do you find the reddish quartzite with the same distinctive hematite-filled cracks and lines that are found in the grinding stone at Harappa. There is even a small local industry devoted to making mortars and pestles from this very same material. As you travel westward back toward Harappa, this distinctive Kalyana grinding stone can be found on the surface of sites like Mitatal in southern Haryana, and at the early Harappan site of Siswal. And numerous examples of Kalyana quartzite were observed on the surface of Kalibangan in northwestern Rajasthan. So these are the four main types of grinding stone raw material used at the site of Harappa and their general source locations. What's fascinating is that you can see patterns of their usage at Harappa change through time. One clear pattern is the ever-increasing acquisition of Kalyana grinding stone from the east. This mirrors what is thought to be an eastward shift of settlement patterns during the late Harappan period. I've examined grinding stones from many other Indus sites, but the largest studies I've done besides at Harappa, are those of artifacts from Dholavira and Rakhigarhi. Now, at these sites, in contrast to Harappa, the grinding stone assemblages appear to be dominated by material from local or at least regional sources. Even so, grinding stone from much more distant sources are present at both sites, like these examples, Pab sandstone. I'll end the discussion of grinding stone here, but not before adding that these are a class of artifacts that should not be relegated to just a few lines in the back of a site report. In the Indus context, at least, they are just as important as prestige materials in terms of what they can inform us about raw material acquisition patterns and trade. Now we turn our attention to Indus chert artifacts. This includes utilitarian items like blades and other cutting tools, as well as standardized cubical weights and the occasional ornament, not to mention the mountains of debitage associated with the manufacture of such objects. A great deal of research had been done on Indus Civilization chert acquisition and distribution networks long before I arrived on the scene. It was noted early on that the high quality brown gray variety that was sometimes banded, like the examples pictured here, were found at sites across the breadth of the Indus realm. The general consensus was that this type of material came from the Sindh region, specifically from one of the many Indus period quarries documented in a series of limestone outcrops known as the Rory Hills. Here, mining pits and pavements of debitage are spread across hectares. More recently, first by Raymond and Bridget Alchin and subsequently by Paolo Biaggi, a geologically related series of sources and Indus period quarries have been documented to the south of the Rory Hills in the Kittar foothill area known as Sindh Kohistan. My work on this subject matter amounted to first searching for other Tangray chert sources across the Indus region and collecting samples with which to compare to Rory chert. The fact is, there are not that many good candidates. I found some in Homand Agency in northern Pakistan, the Salt Range, and the Klat district of Balochistan. But none of these are banded, and truthfully, the quality is, as compared to Rory chert, subpar, but I collected them nonetheless. Using a technique called instrumental neutron activation analysis, or neutron activation for short, I compared Tangray chert artifacts from Harappa to my dataset, along with artifacts from the sites of Dholavira and Nagwada in Gujarat. All of the material from Harappa and Nagwada matched the Rory Hills closely, as did most of the artifacts from Dholavira. Still, some of the examples from Dholavira did plot apart from the Rory Hills, indicating they may be from those sources in Sindh Kohistan, for which I do not have samples yet, or even Balochistan. The lithic assemblage at Dholavira is actually fascinatingly diverse. Although there was a great deal of what appears to be Rory chert in use there, there was also a large-scale industry devoted to utilizing locally available chalcedony. The use of both types of stone appears to be the pattern at many Indus sites in Gujarat. But outside of Gujarat, the lithic assemblages that I've examined are almost exclusively composed of Rory chert. At Harappa, we find large pieces of nodule cortex, which seem to suggest that, along with pre-produced blades, whole chert nodules were being transported hundreds of kilometers to the city and then reduced at the site. To say Rory chert was being used everywhere in the Indus realm is not an overstatement. However, this statement only applies to the urban phase of the Indus civilization. At early Harappan sites, and during the early Harappan phases at multi-period sites, the assemblages are much more diverse. Roy chert is sometimes found in small amounts, but the assemblages are dominated by black cherts and occasionally purple chalcedonies. Here are some examples of black chert artifacts from early Harappan levels at Harappa itself. And here are some examples of black chert artifacts from early Harappan sites in the Punjab and KPK. I collected geologic samples of black chert from 3 sources in Jammu, in Namal Gorge of the Salt Range, and in the Bolan Pass of Baluchistan. Using neutron activation, I compared these sources to artifacts from Harappa and found those artifacts to closely match the black chert from the Salt Range. I'll end the discussion of chert here. I'll only repeat that my research seems to confirm what many before me have assumed, that most high-quality tan-grade chert at Indus sites is from the Rory Hills of Sindh, or perhaps from one of the geologically related sources slightly further south. This is most especially true of the banded variety that was used to make cubical stone weights. I know of no other source of this stone in the greater Indus region. Agate is another stone about which certain assumptions are made. The biggest is that Indus peoples obtained the large majority of the agate that they used from sources in what today is the Indian state of Gujarat. And I have to say that this is a pretty valid assumption. Shown here are examples from the Indus city of Dholavira in Gujarat of just some of the types of agate that came from sources in the region and which were worked at that site. The best known and most sought after subvariety of agate is the translucent reddish-orange material known as carnelian. And it is India, most especially the region of Gujarat, that has been famous for millennia for producing the highest quality carnelian. To the west of the Indus lay the contemporaneous urban societies of Akkadian Mesopotamia. Mesopotamians referred to the Indus as Meluha, and their textual records noted that bright red carnelian came from that region. Jumping forward in time, it is noted in the Periplus of the Etherean Sea that much of the carnelian that found its way to Roman and Greek consumers was obtained from Barigaza, an ancient Gujarati port near the modern city of Bharuch. Even later, during the Islamic period, records indicate that the carnelian that was most prized still came from the Gujarat region, but that the trade emporium had shifted to the city of Kambat. Because of the region's long history of supplying this category of semi-precious stone to the wider world, and because there was a major Indus city there where such beads were produced on a massive scale, it's quite understandable that many would just assume that the agate and carnelian found across the Indus realm came from sources in Gujarat. Even so, it is an assumption that needs to be tested, and that is what I and several of my colleagues have endeavored to do. To set this up, let me provide a brief and simplified review of agate formation. Gas, or water-saturated volcanic lavas, will develop open vesicles as they cool. Over time, as the lavas devitrify, they release free silica, which fills the empty vesicle voids to form agates. The volcanic parent rock eventually erodes, leaving behind loose agate nodules, which are sometimes reconsolidated in sedimentary formations. The rich agate sources of South Asia were mainly formed in the extensive continental lavas that are known today as the Deccan Traps. As part of this research, I've sampled sources where mounds of agate lay loose directly on the surface, such as here at Mardak Bet in northern Gujarat. And I've sampled sources where agates are mined out of consolidated sediments, such as at Ratanpur in southern Gujarat. Altogether, I've sampled 8 major agate sources across the Deccan Traps, 5 of those in Gujarat. Now, to best evaluate whether or not Indus peoples were utilizing these sources, it is necessary to obtain samples from other agate occurrences outside of the region with which to compare these. Agate, of course, occurs in many parts of Asia. Over the past decade, my collaborator in this research, Mark Knoyer, and I have managed to personally collect or obtain from colleagues agate samples from each of these regions. As of this year, over 600 geologic samples representing nearly 40 individual agate deposits have been analyzed. These samples were analyzed at the Field Museum in Chicago by our collaborator, Dr. Laura Ducebu, on a laser ablation inductively coupled mass spectrometer, or LAICPMS for short. The technique basically involves coupling an ICP-MS to a laser unit. Geologic samples and beads are placed into an analysis chamber, and portions of them are zapped with a laser at multiple points. This leaves small pits behind on artifacts, but they are barely visible to the naked eye. The ICP-MS evaluates the material vaporized by the laser and provides quantitative data for over 50 elements and oxides. The data can then be evaluated using different multivariate statistical techniques such as canonical discriminated analysis and principal component analysis. In addition to the 40 plus geologic sources we've analyzed from areas across the Old World, we've analyzed agate and carnelian artifacts from several dozen sites, including a large number of Indus Civilization settlements and contemporaneous sites in Arabia and Mesopotamia. Some of this data is already published, some is in press, but a large majority is still in progress. Here, I will briefly highlight the results from the Indus and related sites. This is a somewhat dated agate trade route map. We've actually analyzed more artifacts from Indus sites than this. However, the basic pattern is the same. That is, at most sites, all or the large majority of agate carnelian indeed seems to have come from sources in Gujarat. At Harappa, Nowshera, and a few other sites not shown on this map, a small number of artifacts seem to be composed of agate that is more closely related to sources found on the Iranian plateau. Moving on to sites in Oman that had contact with the Indus, we see the presence of both agate from Gujarati and Iranian sources. Finally, our very recent and soon-to-be published analysis of beads from the Mesopotamian city of Kish confirms that Meluhha was indeed the source of fine red carnelian. In summary, although material from other sources was sometimes used, agate from the Deccan Traps dominates assemblages throughout the Indus region, and it is now confirmed to have been exported to both Arabia and Mesopotamia. Moving on now to Indus artifacts composed of steatite, which is the massive form of the mineral talc. By far the most abundant type of artifact in this category are beads, disc beads, tubular beads, and microbeads. But it also includes inscribed seals and manufacturing debris and raw material remains. At the site of Harappa, items composed of steatite make up the largest portion of recorded stone and metal artifacts. The renowned bead scholar Horace Beck went as far as to describe the Indus as a steatite civilization. Of all the stone and metal types that I have studied, I have expended the most time and effort trying to understand where Indus peoples acquired steatite and how they used it. One reason is because abundant, high-quality steatite can be found in every major region immediately surrounding the Indus Valley. And I sampled multiple steatite deposits in every one of those regions. I expected to find that Indus peoples exploited many different sources in many different areas, but most especially in southern Rajasthan, which is home to the richest and most extensive deposits. Using instrumental neutron activation analysis, I analyzed nearly 500 geologic samples collected from over 3 dozen sources in India, Pakistan, and Oman. And I compared the data to the analysis of unfired steatite artifacts, mainly raw production debris from Harappa, the other major Indus cities, and a handful of smaller sites. When I compared the artifacts to the geologic database, I found that the large majority came from a very specific type of geologic parent rock and from a surprisingly circumscribed geographic region. The results break down like this. The vast majority of steatite raw material at Harappa, over 95% of it, and most of the material at the other Indus cities and several of the smaller sites seems to have come from dolomitic parent rock in a series of sources that are located in what today is the KPK province of northern Pakistan. Raw steatite from sources in other regions is present at some sites, but only in very small amounts. The pattern is clear and strong. The primary steatite trade network of the Indus Civilization runs from the north toward the south. More recently, my colleague Brad Chase and I began a similar study focusing on steatite beads. Raw steatite is found only at sites where bead production took place, but steatite beads are at every Indus site, usually in great abundance. Not surprisingly at all, we found that the vast majority of such beads were likewise made from raw material derived from northern Pakistan. Okay, with all of these available sources of seemingly good quality steatite, why are Indus craftsmen overwhelmingly choosing to use stone from the northern region? Chert is widely available too, but Indus peoples favored material from the Rory Hills of Sind due likely to its abundance, high quality, and certain aesthetic properties that some varieties had. The same is more or less true of Gujarati carnelian. So what was it about steatite from the north that made it the favored raw material? Finished steatite artifacts have been heat treated. Heating both hardens the stone, making it more durable, and provides it with a lightened, almost white appearance. These are archaeological steatite debris fragments from Harappa that have been heated experimentally. You can see that no matter the starting color, they become bright white after heat treatment. However, similar experimental studies conducted on geologic samples I collected from sources across the Indus region revealed that not all steatite becomes white when heated. Very few do, in fact. Seemingly good quality stone from Rajasthan or Baluchistan will turn brown, gray, or red instead of white. Of all the geologic source samples I tested, the only ones to become white were from the sources in northern Pakistan. This is clearly why Indus peoples preferred steatite from this region. Let's talk now about metals, specifically copper, lead, and silver, which is derived from lead. By studying samples from these metal artifacts on a multi-collector inductively coupled plasma mass spectrometer, lead isotope analysis can be employed in order to identify their geologic sources. I studied various copper minerals from Harappa using this technique. But it was a fellow student of Mark Knoyer's, Dr. Brett Hoffman, that did the largest such study of Harappa's copper artifact assemblage. Much of what I will say about this material is based on his fine research. I have focused on artifacts from other Indus Civilization sites. The Aravalli mountain range of Rajasthan is a particularly rich area in terms of copper resources, and to date, I have focused on sampling artifacts from Indus sites on both its northern and southern margins, that is, on those in Haryana and Gujarat, respectively. My results, combined with those of Brett Hoffman, indicate that copper from sources in both the northern and southern Aravallis found its way to Indus consumers. Copper deposits occurring west of the Indus Valley were also significant sources. What we have not seen is copper that can be traced to Oman. In fact, the opposite may be true. Again, as Brett Hoffman has noted in his research, copper artifacts with an isotopic signature resembling sources in southern Rajasthan have been found at sites such as Tel Abrak in the UAE. More research is needed, but we may have to add copper to the list of Indus materials that, along with carnelian, were traded west across the Arabian Sea. This, of course, is a greatly simplified perspective of what was doubtlessly a complex and dynamic system of copper acquisition and exchange. If we zoom in and focus on the site-wise results from the Gujarat and southern Rajasthan region, we can begin to see the intricacies of the copper trading networks. But this will have to be a discussion for another time. I've analyzed quite a lot of lead artifacts over the years. Here are examples from just two sites, Harappa and Dholavira. Artifacts include lead minerals, rods and rings, melted lumps, slags, and residues in vessels that were almost certainly the remains of lead-based cosmetics like surma. Occurrences of lead, both large and small, are found in every region surrounding the Indus Valley. The results from isotopic analysis indicate that while lead from deposits in southern Baluchistan was the most widely used, there was also material traceable to sources in northern and southern Rajasthan, as well as the foothill region of Jammu. Turning now to silver. In ancient times, this precious metal was extracted from silver-rich sulfide mineral deposits. Usually these were lead deposits, but could also be copper or other polymetallic occurrences. I've been able to analyze a few dozen silver artifacts from a number of Indus sites. The acquisition pattern is almost the same as it was for lead. Some silver seems to have been made from metal coming from Rajasthan, but the majority was derived from sources in southern Baluchistan. And this is very interesting because there are hectares of ancient lead workings within a few dozen kilometers of the Kuli Harappan site called Sowardamb. And it's probably no coincidence at all that silver grave goods have been documented at that very site. My time remaining for this talk is short, but there are a few other material studies that I need to briefly mention. Large ringstones made from a distinctive banded limestone have been found at both Harappa and Mohenjo-daro. Banded limestone artifacts from Harappa were compared using ICP-AES to samples from several potential source areas throughout the greater Indus region. And they were found to closely match samples from an Indus period quarry adjacent to the site of Dholavira in Gujarat. Lapis lazuli is a widely recognized semi-precious stone that, while not as abundant as agate, is not especially uncommon at Indus sites. Its primary source in the Badakhshan province of Afghanistan is well known. But about 40 years ago, there were reports about the existence of another source in the Chagi hills of Baluchistan, which had the potential to change our understanding of this stone's ancient trade routes. As it turns out, however, that alternate source doesn't actually exist. Deposits in Badakhshan were the only viable sources, and sulfur isotope studies of Indus lapis lazuli artifacts closely matched them. And I also want to mention that I don't consider lapis lazuli to be an exotic raw material from some far distant land. It's true that the deposits are remote and difficult to reach, but they are more or less adjacent to the Indus region. And Indus peoples, as evidenced by the site of Shortagai in northern Afghanistan, were more than capable of making the journey to them. Early excavators and researchers at Harappa and Mohenjo-daro identified the translucent green beads on this necklace and others like them as being composed of jade. They and subsequent scholars considering trade networks pointed to them as possible evidence of long-distance contact with regions such as China and Myanmar. It turns out they are not jade at all. X-ray diffraction analysis revealed that they are composed of a mixture of Vesuvianite and Grosvenor garnet, several sources of which exist in Pakistan and northwestern India. When we compare geologic samples from those sources to Vesuvianite Grosvenor production debris from Harappa and Mohenjo-daro, we found that Indus peoples had been exploiting deposits of the stone in both northern and western Pakistan. Now, this is not to say that there was no jade at Indus sites. This amulet from period 3C at Harappa has a specific gravity, crystalline texture, and an X-ray diffraction pattern that is consistent with nephrite jade. There is little doubt that this is genuine. However, it is doubtful that the raw material came from China. And that is because a source of nephrite with the same appearance was identified in the Kohat region of Pakistan some 60 years ago. All of this is not to say that there are no examples of stone and metal from outside of the greater Indus region. There are numerous examples, in fact. A few that I've gotten to study firsthand include a Persian Gulf style seal, an Arabian chlorite vessel fragment, and a chlorite vessel fragment and variegated calcite vessel fragment of the types associated with the ancient cultures of South Central and Eastern Iran. I actually analyzed this black steatite wig from Harappa, which would have adorned a BMAC figure from Turkmenistan, and I can tell you with certainty that this is not made of steatite of the variety typically found in the Indus region. These and other artifacts like them are important evidence of long-distance external contacts, but they are exotics and, in the grand scheme of things, exceedingly rare. In summary, when I superimpose upon one another all of the stone and metal types that I have discussed here, the result is a colorful but confusing web of sources, nodes, and routes. It may instead be preferable to summarize Indus stone and metal trade networks in this manner. The first thing to note is that there is not a single material variety, of which I am aware, which was used by Indus peoples that does not occur somewhere in the greater Indus region. Any notion that the Indus civilization was somehow reliant on external trade for any critical resource is wholly unfounded. In fact, for nearly every material variety, there were multiple potential sources. The principal Indus cities and their satellite settlements could, if necessary, have relied solely on resources from adjacent highland areas to supply almost all of their raw material needs. This may have been, in part, a factor in the development of these urban centers. Even so, and despite the wide availability of secondary raw material sources, there were certain key stone and metal types that came from very specific deposits in very specific regions. Now, this could have been because of their abundance and ease of access, or their quality, or certain aesthetic or technological properties, or even some combination of any of these factors. Agates from Gujarat, chert from Sindh, steatite from the far north, and copper from Rajasthan. These were clearly favored throughout the Indus civilization. Of course, this talk was meant to be an overview of patterns of trade, and as such, is a simplification. The ancient reality was undoubtedly orders of magnitude more complex. I tried to provide a glimpse of this complexity when I briefly showed a map of copper trade networks in Gujarat. But even this, which is essentially a palimpsest of multiple chronological phases, is a vast oversimplification. At a site like Harappa, where there is fine-scale stratigraphic and horizontal data, it is possible to examine and consider these complexities. This, however, will have to be a talk for another time. I want to again thank Uta Franca and Vian Prabhakar for inviting me to participate in this wonderful series of talks. And thank you all for listening. Please do feel free to contact me with any comments or questions that you may have. Have a good day, and adios.